Do I do it? Yeah.
Your marker fell on the floor.
Oh, thank you.
The bloopers.
So you want to calculate the energy and wavelength of a photon with a frequency of 7.02 times 10 to the 14 hertz. So frequency is 7.02 times 10 to the 14 hertz. And you want to find the energy and also the wavelength for this photon. So to find energy is h nu. This h is Planck's constant. This is frequency. And obviously this is energy. So Planck's constant, you can find it in your periodic tables, I believe, in the back of your periodic tables. That's 6.626 times 10 to the negative 34 joule seconds. And your frequency is 7.02 times 10 to the 14 hertz. So for your hertz, you could just assume that the unit of hertz is 1/second. Or if you want to convert that from hertz to seconds, 1/hertz is 1 second. So this way, hertz and hertz cancel out, second and second cancel out. You end up with a unit of joules for the energy. So 6.626 times 10 to the negative 34
4.65 times 10 to the negative.
times, are you giving me the answer?
Yes.
Right.
Is that the answer?
Hold on.
4.
So I have 4.65 times 10 to the negative 19.
Yes,
Yeah.
ma'am.
All right, and we want 3 significant figures, so that's 4.65 times 10 to the negative 19. And we were solving for energy. The unit is going to be joules. Questions? Now, we also want to find the wavelength. So energy equals to hc over lambda. This is where you see the lambda for wavelength. So h is Planck's constant. C is also a constant. That's the speed of light. Lambda is your wavelength. And keep in mind that in this equation, your lambda has to be in meters. This is joule times second. The speed of light is meter per second. And energy should give you joules. Now, to find the wavelength, we already find energy. You can just plug it into this equation, and you can find lambda. So there are a couple of ways to find wavelength here. One way would be plugging in to the energy equation, or I show you another way that you could solve for lambda. So energy is 4.65 times 10 to the negative 19 joules. Planck's constant is 6.626 times 10 to the negative 34 joule second. Speed of light is 3 times 10 to the 8 meter per second, and you're solving for lambda. So lambda from here, so that's 6.626 times 10 to the negative 34 times 3 times 10 to the 8 divided by, yes, 4.65 times 10 to the negative 91. And this is 427 nanometers. So what I get from the calculator is 4.27 times 10 to the negative 10. 1, 2, 3, 4, 5, 6, 7. but convert this to nanometer, that gives you 427 nanometers. So the other way you could solve for lambda was by using this equation. Look on the other side of the board. Lambda is C over nu. So you could try with 3 times 10 to the 8 meter per second over our frequency, which is 7.02 times 10 to the 14 hertz. And that should give us the same thing. Is this correct? Is the answer correct?
Mm-hmm. Yeah.
So if you have energy, you can use this equation. If you don't have energy to convert in between wavelength and frequency, you can just use lambda equals to C over nu. Does anybody have any questions? So the second part of this question is the same thing, right? You use just that lambda equals to C over nu to solve for the second part too. Did you have a question?
Oh, that's what I was gonna ask you about the 365 nanometers.
So you convert that 365 nanometers first to meters, and once you convert it to meters, then you plug it into this equation. That's the trick. Okay, can you stop this please? Pause it.